Start.
Hello everyone, my name is Harika. I am here with my team members Swapna and Niharika. Today we will be presenting on our project Emotion Detection on Twitter using transformer models and RAG based ensemble learning. In this presentation, we will explain what our project is about, what steps we followed, show you some results, and finally share our conclusions. The main goal of our project is to detect emotions in tweets more accurately. Tweets are very short and sometimes they don't give enough information for computer model to understand emotions clearly. Traditional models like basic BERT work well, but sometimes they miss the emotions that are hidden in short text. To solve this, we used a technique called retrieval augmented generation or RAG. We combined a fine-tuned BERT model with a knowledge base that gives extra information about the emotions. This extra context helps the model understand the tweets that we use betterly. This project is useful in many areas like social media monitoring, understanding customer feedback, and brand analysis. So, coming to dataset overview, for training and testing our model, we used the Sentiment 140 dataset from Kaggle. This dataset is available on Kaggle and contains about 1.6 million tweets. The tweets are already labeled based on sentiment using emojis 0 for negative, 2 for neutral, and 4 for positive. Each record includes a text, user ID, and the sentiment label. Since training with 1.6 million tweets would take a lot of time, we selected a subset of 10,000 tweets for our project. This made it faster for us to train and test while still showing the concept clearly. The dataset is good fit because it has real world language with abbreviations and informal writing, just like normal Twitter posts. So the methodology is first we process the data. We clean the tweets and map the labels from 0 to 4 into new labels, that is 0, 1, 2, so that the model can learn easily. Second, we fine tuned a BERT model. This means we trained already powerful model to become even better for our special task, which is emotion detection. Third, we created a small knowledge base. It contains emotional definitions like happiness, anger, and sadness, for examples. Fourth, we used a retrieval system. We encoded each tweet using sentence BERT and searched for the best matching emotional detections from the knowledge base. Finally, we combined the original tweet with the retrieval knowledge and gave the enriched text to the BERT model for final prediction. These steps helped our model understand not just the tweet but also the hidden emotions behind it. Further slides will be explained by Swapna.
Hi everyone, I am Kranti Swapna Garpati. I am going to explain the model architecture for this project. These are the steps for the model architecture that we are going to follow here. And the architecture for the project here, it is this one. The input is that tweet that we are giving, taking the input tweet, something example like feeling great today or some negative feedback, negative sentence that we are going forward pre-processing that step. In the pre-processing step, we are going to eliminate unwanted special characters and everything. And later on, we are searching in the knowledge base for the similar kind of sentence. So in the context fusion, we are combining the original sentence that are from the pre-processing step and the knowledge based one. After that context fusion one, we are using the fine tuned BERT classifier to classify the sentence whether it's going to be neutral sentence or positive sentence or the negative sentence. Then we are giving predicting that output accordingly what we had received from the model. So for the live code demonstration, we are using these 8 steps, including the step 0. Each step I will explaining the code along with this one. The first step, 0th step, we are installing the all the libraries required for this project. So now I am going to explain the all the steps that we had here. So the step 0, we are installing the libraries and the Kaggle API setup. We have used the transformers and the fuzzy and the scikit-learn and the pandas and the Kaggle for the data sets. In the step 1, we are uploading our Kaggle credentials and downloading that data set from the Kaggle. In this step 2, we are loading and preparing the data sets. We had using this Kaggle, this data set from the Kaggle, which has 1.6 million data, and we are you can see it has the columns target and ID, date and flag, everything over here. In the step 3, we are querying encoding that tweets what we had received from that Kaggle. Here we are using the BERT based model. In the step 4, uh, building the by using that knowledge base and the retrieval the fuzzy. Like as I told you, we are searching similar kind of sentence in the knowledge base. Here is the step that we are searching for the similar kind of steps. So in the fifth step, we are combining the original sentence. You can see the tweet that we had used for the original one and that we are combining with the knowledge based sentence here. In the sixth step, preparing the data set for the fine tuning. For the fine tuning, we are preparing the data for the preparing the data for the fine tuning what we had received in the context fusion one. In the seventh step, we are using the fine tune transformer to classify the sentence. Here you can see the try number of epochs is 0.01 because I just want to show here to see the results easily. And in this eighth step, we are predicting the sentiment analysis for the tweets. I had given I don't love how everything is working out today. So it's even I had given love as a positive one, but in before I provided don't. So it will take obviously it will take as a negative sentence. So our prediction is negative here. So for here we had plotted the graph for the BERT and BERT plus RAG based system confusion matrix and the retrieval performance for the recall one score one. You can see all the graphs over here. And we had also comparison the BERT versus BERT plus RAG based system here. Yeah, all these are the 8 step we had followed over here. As I told everything in the code demonstration, all the results over here. And the next slides will be explained by Niharika.
Uh, so the results are for the accuracy, we can see that the model correctly predicted like 87.5% of the tweet sentiment. Precision model, it predicted the correct sentiment like 87.2% of the time. Recall, it identified 87.4% of all actual sentiments. F1 score balances precision and recall, reflecting strong overall performance. By adding RAG to BERT, we saw like about 3 to 4% improvement across all the metrics, particularly in classifying neutral trains. So conclusion is combining RAG with BERT boosted sentimental classification on short noisy tweets by leveraging external knowledge to capture subtle emotion cues. And the future enhancements would be for the better retrieval, adopt more advanced methods for higher quality of context, larger data, train on a wider variety of tweets for stronger generalization, domain tuning, fine tune on industry specific data, example, customer reviews, political post, etc., and efficiency, optimize for faster real time interference. Thank you.